right? So you'll be learning about geometry from lesson 4.7 from today, which is applying trig functions to finding missing angles in the real world situations. And the whole point of it is that you can, after this, apply trigonomic functions by using inverse functions to determine the acute angles, measures by right angles or right triangles in real world situations. So first is the practice problem, which states, draw out the following situation and then place the correct information on the diagram. And we have it right here. So let's get started. A ladder leans against a brick wall at the foot of the ladder, which is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find the nearest degree, which is a whole number, at the angle at the bottom where the ladder makes with the ground. So that means the ladder is is 6 feet, 6 ft from the wall. Why does it do that? Can I just, okay, with this one I can. Control Z. Alright. Which is 15 from the wall. So now we can just finish our right triangle off like that. Just finish it off like this. And yeah, so we have first our 6 feet and then our 15 feet. And we use the one where it meets with the bottom of the ground. And from the wall, which is our 15 feet. So we're using this angle, which means that we will be going like. And in geometry, we use the simple. We use the. I wouldn't say simple, but we use the basics of tan. No, let me start. Like, okay, sin, cos, and then tan. Let me change the color. Alright. So, now with that, we just go on with our basics. So, because this is the angle we're working on, the longest angle is from our right triangle is our hypotenuse. The angle that is right next to the hypotenuse, or the angle that we're working with, this being our 6 foot and our hypotenuse, which makes this our adjacent, which we can just find off with ADJ, and then the angle across from it being our opposite. So we're not using H because there's no number for it, there's no nothing for it. There's nothing that can help us find H, and we're not even trying to find H, we're trying to find the angle. Let's call this X. So now we are only using our 6 and our 15, which gives us only the availability of tan, since sin is SOA. No. SAH and then COH, but tan differently is TOA. And the H being our hypotenuse, which we're not using, so it crosses all these out. So in situations like these, when we're not trying to find the length but the angle, we don't use normal tan in our calculator, but we do tan minus the power of 1. And then we just put in our numbers, which is first 15, because it's O then A. So 15 over 6. And if we go back, we can go, so arctan 15 divided by 6, which gives us this whole bunch of numbers. So let's just put it down, which was 68.19, which was the first thing I remembered. But as it says in the question, as I restate, find the nearest degree, which is making it a whole number. So we cross out that and we say x is equal to 68 degrees. But what we are mostly learning about in this is the angle of elevation versus the angle of depression, which is very important vocabulary in this lesson. So the angle of elevation is pretty much when you're looking up. So like an elevator, or elevator is going up. And it's pretty much anytime you look up. So if you were to say, look up at like a helicopter in the sky or a plane or whatever, in this case being a plane, it would be the angle of elevation, which makes you look up. And then if it's just a straight 40 or a straight 45, that is horizontal. And then the angle of depression is when you look down, which is in this case looking at a dog. So and the next page is our big question, which is currently tallied at 6 points on the regions, which is awesome, because now that we learn this, we can just get a free 6 points and work with everything else, And I'll just highlight whatever's important. So Jeremy is looking down from his window and observes Sarah holding a balloon. Oh shit. Okay. I didn't get all of it, which is kind of bad. But the balloon reaches 15. Oh my fucking god. Can we get that more transparent? Alright, thank you. Alright, the balloon reaches 15 feet above the ground. So that would be the balloon up, which is important info. And the first question on this is, she stands still and the wind moves the balloon 6 feet away from her. What is the angle of depression Jeremy makes with the balloon from her now? Jeremy being this little lad. But the number we should take away from this is 5 feet. Okay, so we have little Jeremy here, and the balloon. Fuck it, we're not using a balloon. Say there's 2 powers. Fuck it. That's how you do it. Okay, so there's 2 powers. There's one over here, copy, and there's one over here. And let's just say this is power blue, and this is power red. And again, let's just group, and now we can continue. So if let's just say a little fella over here is holding a little power on a string over here, and then power red, she gets blown away a little bit, and from what we know, the balloon reaches 15 feet off the ground, so this makes this 15 feet. What the fuck? And then it makes the distance between power red and power blue 6 feet. Now we need to find the angle of depression, which is the fella over here. We need to find out how they see this angle over here. So the way we would find this out is we would okay, if we're trying to find the angle of depression, that means we're looking down and not up. So if we were learning, if we're looking for the whatever's the opposite, my fault, the angle of elevation, we would be looking this way, but because we're learning depression, it's going down. So we're gonna go there and then down. So that means this is 15 is opposite, and that the 6 foot is adjacent. Okay. So, firstly, we would know that the basics of this, it would have to, since there's no adjacent in this equation, that means this one's out and this one's out, and that only leaves tan opposite adjacent. So we would put in our calculator again, we would put tan minus 1 in parentheses 15 over 6. And because we already did this question before, we already know the answer, which is 68. Okay. That was for question. I'm gonna write my little boots the cats. Cardi. Alright. So now, whoa, what did I even click? Yeah. So now we have all this. Okay. Man, just give me my money. Alright. What the fuck? Alright. Now question 2. The balloon is still 15 feet, so our first number being 15 feet. And let me read off the paper. And the string is 16 feet long. So the string is 16 feet long. What is the angle of elevation? I should also highlight the angle of depression that Sarah makes with the balloon. Sir, because it doesn't say this anymore, and we also know that it's the angle of depression now, we can just remove all this, flip this, bring it down here. So it restates again that the line is 15 feet, but we also get our second number, which is 16.2. And we would know that it doesn't go over here because before it already stated that this was 6 feet away. And it would have said something like, oh, it moved, but no, it just says the string is 16 feet long. What is the angle of elevation, which puts our reasoning to putting the angle that we're using over here. Let's just, again, put this as x, that Sarah makes with the balloon. So this is little Sarah over here with her curly hair and her 2 powers. Okay. So we need to find the angle of elevation, which are most important where there's angle. So we first just go like that, and we find the angle that x happens to be. Okay. So we obviously know that this is adjacent, being the longest side of the right triangle. And yeah. So we're using O and P, or O and H, which is sin, since there's no O in this and there's no H in this, so it's SOH. So in our calculator, we will put, like I'm being jelt right now, my fault. Sin 1, or sin minus 1. Okay, let me just recreate that one. And we would put 15 over 16.2. And we would go and find that out right now. So calculator.net, we go back, we go sin minus, whoa. Alright, sin minus 1, 15 divided by 16.8, Oh no, my fault. Back 16.2. And that gives us this jumble of numbers right here. So let's just copy this down real quick. Copy. Paste. And now Control Z. Whoa. That gives us our little thing. And we have this little circle above it. Did I put the right numbers? Wait a minute. Did I put the wrong numbers? Wait a minute. O H 15 over 62. Oh no, wait, degree. That's weird. Anyways, since we're just trying to get the degree, hold it down. So mix with powers. Okay, so let's just, of course, because it doesn't say what we want, we're just gonna round up, and we're just gonna say this is 68. And then our last question, what do we know about both the answers? And which is simply that, add subtext, that they both made, oh, holy, I'm good at math, not numbers, or words. Whoa. That they are both the same. Simply, both the numbers equaled. If I can move it, holy, they're both the same. They both equaled up to 68. If we round it, of course. But, they both equaled up to 68.